So once again, we have here the syntax to create an instance of a class. Okay, so class name, instance name, the new operator, constructor is this one. The constructor is simply a method call. Class name is the method name of the constructor and then some arguments. And to access the methods and the fields of the instance, these are the syntax. Okay, so to call or access a field via the instance name and to call the method via the instance name. Now we have here two classes. The first class is employee, and this is the called class. And the second class, director, is the caller class. So inside the main method of this class, director, we have here an instantiation of the called class employee. So this is the class name, employee, the one which is called, and the instance name is emp, the new operator, and this is the constructor. And so since we now have an instance of this class employee, via the instance, we could then call or access the method today task, okay, using the dot operator. So since this method is called, so this is executed and the output would be to display this on screen. That's why we have this output. In here, we have the default constructor. We call this the default constructor with 0 arguments and an empty method implementation. If in this case, what we have here is a default constructor, you can actually just remove this one, just like what we did here in student. We don't have a default constructor here because it will be automatically created by Java compiler once the class is instantiated. As mentioned earlier, a constructor is a special method which provides initial values to the instance variables. And a constructor is called only when the class is initialized or when it is instantiated. So again, a constructor is called only when the class is initialized or when the class is instantiated. It cannot be called anytime you want it. It will only be called during instantiation. So a constructor cannot be called like an ordinary method. It is only called during instantiation, not anytime you want. And defining a constructor can be omitted, just like in our previous example with student and student assessment. We don't explicitly define a constructor in the class student. So a constructor definition or declaration can be omitted. If it is omitted, as mentioned also earlier, Java will automatically provide or create a default constructor. Now, multiple constructor can be defined for a class as long as they each have different patterns of arguments. When we say pattern of arguments, we are referring to the number of arguments, the data type of the arguments, and the order of the arguments. What we refer as pattern of arguments are these three items. First, the number of arguments. Second is the data type of the arguments. And third is the order of the arguments. These three are what we refer to as the pattern of method arguments. The caller class, take note, can identify which constructor is to be called since there could be multiple constructors in a given class. It is the caller class which can identify which of the multiple constructors is called for the instantiation depending on the argument pattern. The syntax of constructor declaration is given by the following. So this is actually optional, the keyword public. This is access modifier. So you can omit that. In that case, if you omit that, you are using actually the access modifier, no keyword. But most Java classes would use this access modifier public. That is if you want this class to be accessible to the whole project. So again, for the syntax, we start with the access modifier, say for example public, and then followed by the class name, then the arguments, which could be 0 or more arguments. And we have here the implementation of the constructor, or the implementation refers to the set of statements to be executed. And these statements are actually initializations of the class fields or the class variables, because that is the very purpose of a constructor, to initialize class fields or class variables. And this is the syntax for the default constructor as I have already given to you earlier. So you have the access modifier, public, in this case, the class name, 0 arguments, and then an empty implementation. We have here another example of two interacting classes. Pet here is the called class and keeper is the caller class. So we have here the main method, so we can execute this Java class because it has the main method. And we have here two instantiations of the same called class pet. So pet, the called class, is being instantiated twice. And in the first instantiation, we create instance P1. So the first pet is P1. On the second instantiation, we create the second instance P2. So the second pet or instance of pet is P2. On the first instantiation, we use the first constructor. Okay, so take note, in the called class, there are two constructors. This is the first constructor and this is the second constructor. Okay, so these two constructors are different because they have different pattern of arguments. In here, in the first constructor, the argument is empty. In the second constructor, the argument is not empty. It has one argument, which is P name. If the first constructor is used, then the pet's name would be set to dragon. If the second constructor is called or used, then the name of the pet is the whatever is provided here as the value of pname. So as you can see here, when we run this Java class or this program, since it is using the first constructor, the name of P1 is set to dragon, right? And when we create the second instance P2, we use the second constructor. And since we pass this string value, Winnie, that is actually the value of the argument Pname here, then the name of the second pet, P2, is set to the value of Pname, which is Winnie. So P2, that name, is equal to Winnie. So that after these two instantiation, creating P1 and P2 and setting names to P1 and P2 using the constructor, when these are executed, the method called getName here will simply display on the screen I am, and then concat the name of the pet. In this case, since this is P1, the name that will be displayed here is the name of P1, which is dragon. That's why the output of the method call P1 dot get name is I am Dragon, sir. For the second method call, P2 dot get name, the output is I am, and the name of P2 is Winnie, and then sir. Thus we have this output. There are two types of fields and methods of a class. The field or the method is either static field or method, or it is non-static, or also called instance field or method. So these are the two types. First, a method or a field can be static or it can be non-static, or another more familiar or popular name for that is instance. If the field or method is not instance field or method, then it is called static field or method. Now, what are instance method and instance field? Okay, let's focus on the second type, the non-static or the instance field and method. What are this? What are non-static or instance method and instance field? These are the characteristics of instance method and instance field. First, they cannot be used without instantiation, okay, using the new operator. That is why, as you can see here, ID up to year level are non-static or instance fields. Since these are non-static or instance fields, we can only access them via an instance, by creating an instance using the new operator. That is why we need to create an instance of this class, the cold class student, and this is the instance name, so that via the instance name S, we could access the non-static or the instance fields. So again, number one is you cannot, this instance or these instance fields or methods cannot be used without instantiation. That is why we instantiate the class, creating the instance S. And second characteristic is it is allocated in each instance. So for example, we would like to create another instance, S2. So say we have another instantiation. Say this is S2. Okay. And when we access S2 and then that operator, take note that this second instance S2, another student S2, S is one student, S2 is another student, and take note that the second student has also all of these fields. We could access all of these fields via instance S2. We could say, for example, this is S2, 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 and say we have another value for student. So this is the record of the first student S, whose ID is this one, whose name is this one, whose course is this, section, and year level. And this is another student record referring to another student, S2, and say the student ID of S2 is 2018 0113, and say this is Maria Clara, and say the course is ECE, and the section is ECE. Say this is 2B, and the year level is second year. So take note that all the instance methods and the instance fields, these are the instance fields and the instance method. Okay, we could access also the method s2 dot, okay, compute grade, and say this is 89, this is 90, this is 95, and say this is 91. So these are the scores of the second student S2, whose name is Maria Clara. So take note that all the non-static or instance fields and methods are allocated to each instance. So one instance S has all of these allocations, the instance fields and the instance method. And another instance S2 is allocated also with all the non-static or instance fields and instance method. So take note of the second characteristic of instance method and instance field. They are allocated in each instance, like S and S2 and all the other instances of the class. Third characteristic is that these instance fields can hold different values on each instance, okay? Like for example, this one. For the first instance S, hold values which are not the same as the values of the instance fields of another instance, okay? So the instance fields may have different values among different instances. Like this one, different values, and this instance fields have also different values. So as depicted here in the figure, we have one class, okay, say in our example, it is student, and then we have here, say, first instance is S, second instance is S2, and maybe if we have a third instance S3, all of the instance methods and instance fields will be allocated to S, to S2, and to S3. So we have here s.id, s.name, up to s.compute grade, the non-static or instance method. S2 also has S2 ID, S2 name, up to the last S2 compute grade. S3 also has S3 ID, S3 name, up to the last instance method, S3 compute grade. So all of the instance methods and instance fields are allocated to all the instances, and these instance fields may have different values.